Good evening, dear students. As you can see in the screen, this time is 7:51 p.m. and we are having a biomolecule lecture number 2. Lecture number 1 I have already prepared. In that case, a small kind of introduction and about the glucose we discussed. In the lecture number 2, we are going to discuss about the classification of carbohydrates. Okay. So let's talk about the classification, guys. So classification of carbohydrate. Classification of carbohydrates. Okay, this is the topic for this lecture. If we are having time, then preparation of glucose and something about the glucose also we will discuss. So let's see how much we are able to complete. In the case of classification of carbohydrate, first classification on the basis of functional group. On the basis of functional group. In that case, carbohydrates classified into two category children. Polyhydroxyaldehyde, where aldehyde group is there and where ketone group is there. So it's called polyhydroxyaldehyde and it's called polyhydroxy ketone. If we are talking about the example, so glucose is the example of polyhydroxyaldehyde and fructose is the example of polyhydroxy ketone. Okay. Second classification on the basis of reducing sugar. On the basis of reducing sugar. Sorry, not sugar. On the basis of reducing nature. Here also two type of classification: non-reducing sugar, non-reducing sugar and reducing sugar. Non-reducing sugar and reducing sugar. Okay, what is the meaning non-reducing and reducing? Tolerance and Fehling reagent. We are talking about tolerance and Fehling reagent. You know that tolerance and Fehling are mild oxidizing agent. These are the mild oxidizing agent. Okay, so in that case, according to the tolerance and Fehling reagent, in that case, reducing nature, non-reducing sugar, example sucrose. Okay, and here reducing sugar, all monosaccharide, all monosaccharide, all monosaccharide like glucose, fructose, maltose, lactose. Okay, so non-reducing sugar and reducing sugar. According to the, on the basis of reducing nature, two kind of carbohydrates we are having: reducing sugar and non-reducing sugar. So check it once again. I am telling you, first classification on the basis of functional group, so aldehyde and ketone. On the basis of reducing nature, so non-reducing sugar and reducing sugar. Saccharide, sucrose is the example of non-reducing sugar, and all monosaccharide. Monosaccharide means single sugar. Monosaccharide means single sugar, like glucose, fructose, maltose, lactose. They are reducing sugars. Okay. So next classification, on the basis of sweetness. Number 3, on the basis of sweetness. Here also two kind: sugar and non-sugar. According to the sweetness nature, sugar which is sweet, non-sugar which is not sweet. Simple thing. Okay, so here no need to worry, so just simple part. Here one thing you can write: saccharide. Sugar means saccharide. Saccharide. Okay, so this saccharide word came from the Latin. It's a came from Latin, from Latin word saccharum. SCHSSACCHARAM. Saccharide made from the Latin word saccharum, and saccharum meaning is sugar. Okay. Now the next classification, number 4, on the basis of number of carbon. On the basis of number of carbon. In that case, carbon number 3, 4, 5, 6. 3 carbon, then triose. 3 carbon, then it's called triose. TRIOSE. Here the OSE means sugar. It is meaning is sugar. Okay. Then tetrose, then TETROSE. Pentose, hexose, on the basis of number of carbon. Simple. If CHO group is present, then it's called aldose. If CO group is present, then it's called ketose. Okay. So one important thing we are writing here, focus on it. If a carbohydrate has 4 carbon and CHO group, 4 carbon and 1 CHO group. Then what is the name, children? Then it is total number of carbon 4 and this carbon 5. So it is aldo aldopentose, pentose. It is aldopentose. Okay, aldopentose. Or if a carbohydrate has 5 carbon and 1 CO group, then total number of carbon, children, 5 plus 1 6. So it is ketohexose. Name will be ketohexose. So that is the important part. So 4 classification done. Next classification, number 5 and last classification of carbohydrate. On the basis of number of product of hydrolysis. On the basis of number of product on hydrolysis. Okay, this is the number 5 classification. On the basis of number of product of hydrolysis. In that case, it is classified into 3 category. Monosaccharide, oligosaccharide, and polysaccharide. Okay, monosaccharide means they do not undergo hydrolysis. They do not undergo hydrolysis. Example, glucose, fructose, ribose, etc. So children, it's just simple. You can think it. If you are mixing glucose in water, then what you will get? Only liquid glucose. Only liquid glucose, nothing else. No product formed. That is why glucose is your monosaccharide. If we are talking about oligosaccharide, on the hydrolysis, it gives 2 to 10 unit. How many product unit? Gives 2 to 10 unit of product. Example, sucrose and maltose and many more. Polysaccharide give more than 10 unit. Give more than 10 units. Examples, starch, glycogen. In the beginning I told you in the glucose topic, This is the biopolymer, cellulose. Okay, so these are the examples. So this is all about the classification of glucose. Classification of glucose is completed now, children. Let's talk about classification done. Monosaccharide. In monosaccharide, we will study about the aldohexose and aldoketose. Here only I am telling you. In monosaccharide, we will study about aldohexose. In that case, glucose, galactose, and mannose. In the case of ketohexose, we will discuss about fructose. These topics we have to discuss. Okay, so this is simple thing, no any difficult part. Let's talk about the preparation of glucose. Preparation of glucose. So number one, hydrolysis of, how to prepare hydrolysis of cane sugar. If you are doing hydrolysis of cane sugar, then it is prepared. So what is the reaction? C12 H22O11. This is your cane sugar. Hydrolysis means we need water in the presence of acid catalyst H2SO4 or HCl. It will be break down into C6H12O6, C6H12O6. One is glucose and one is fructose. What is the percentage formation in this case, children? How much percent glucose and how much percent fructose form? So it's very simple. Many times we will confuse. Equal percent, 50% glucose and 50% fructose will form. So no need to worry at all. Same work you can do with the boil in presence of, if you are boiling cane sugar, in presence of, presence is spelling wrong, in presence of alcohol or the enzyme, which enzyme, children? Invertase. Invertase enzyme. Okay. Invertase can cause the reaction. Can cause the reaction. Okay. Same work will be done by these alcohol or enzyme invertase. They can also form glucose and fructose. If we are talking the commercial commercial method. So at the same time, we will discuss the commercial method. Here we will use starch or cellulose C6H10 C6H10O5 N unit. What it is? Starch or cellulose C6H10O5. Then N minus 1 water molecule. Suppose in that N place 5, then 4 water molecule in the presence of acid catalyst. That acid may be HCl or H2SO4. No problem. What is the another condition? 398 Kelvin. Temperature should be 398 Kelvin and pressure will be 2 to 3 atm. Then n number of glucose C6H12O6. N number of glucose will be formed. Okay. So that is the formation, children. Structure evidence about the glucose structure we will discuss in the next video. So I hope you people are doing good. All the very best for your exam. Do hard work, prepare well. Thank you and all the best.